Right. Appendix A, B, and C are kind of preparatory for the class, but there's some good principles that are involved there. And we just want to make sure that some of the algebra skills that we might be called on in this class are kind of well remembered. And so what we've done is assign some problems out of Appendix A, B, and C. And so this is some practice that will highlight some of the homework that you're doing. It should all seem familiar, but we'll go through these examples that are on the next pages for this A, B, and C, and they give you some examples to look at in addition to what you can find in your book. And so as you look at 1A, we're hoping that you're not daunted by that you say, oh, I know how to solve a rational equation or an equation that has fractions in it. You're going to clear out the denominator by multiplying everything through by 10. So we're going to come in here and we are going to multiply every single thing by 10. And I'm going to go and put a 10 next to everybody, just like you would. And you know the 10s are going to cancel in that first position, leaving you 3x plus 6. Minus, from that minus in between, half of 10 is 5x, equals 5 goes into 10 twice, times 2 is 2x, and 5 goes into 10 twice, times 33 is 66. And so everything gets multiplied by 10. Then you put together what you can. So what you have on the left hand side is those x's coming together to give you 6 minus 2x. And on the right hand side, everything is good. I would recommend getting the x's together and get 6 is equal to 4x minus 66, or 4x is equal to negative 60, or x is equal to, and then how many times does 4 go into 60? Let's see, you might not have it memorized. Maybe you can figure it out really quickly. It's 15 times, but don't forget that it's negative, right? So a negative 15 coming out of that. Hopefully you remember how to solve something like this. X squared plus 6x equals 3. We would move over that 3 and hope that it factors, and find out very quickly that it doesn't. There's no factors of 3 that subtract to be 6. So we know that solutions are either going to be irrational or possibly not even exist. So let's take a look. Some would use the quadratic formula. Others would complete the square. Completing the square would be so much faster. So I want to just show that. So if I'm going to erase and go back to the beginning. Completing the square would say, hey, take your x's that are isolated and add something to them so that it creates a perfect square. And then do the same thing to the other side. So again, we should be teaching you something that was both Algebra 1 and Algebra 2 as a reinforcement coming through, but 3. And then let me just highlight what I added by putting it in a different color. And so what do you have? You have x plus 3, the quantity squared, is equal to 12. You have x plus 3 is equal to plus or minus root 12, or x plus 3 is equal to plus or minus 2 root 3, right? 4 times 3 is 12, square root of 4 is 2, and then all you have left to do is move that over. Very quick to do it that way. And it's exactly what we expected, an irrational solution. If we would have used the quadratic formula, we would have brought that 3 over, and it's not going to be bad. Negative 6 plus or minus the square root of b squared minus 4 times a times c, all over, the whole thing over 2 times a, right? And so you'd put yourself in this little bit of a pickle. 36 plus 12 all over 2. You'd have to recognize that this is negative 6 plus or minus root 48 all over 2. 48, if we look to simplify that, that's 16 times 3, so that's negative 6 plus or minus 4 root 3 all over 2, and you can take a 2 out of everybody and be left with exactly this. So if you completing the square hands down beats the quadratic formula in terms of speed. But we're not teaching anything you didn't know. Inequalities, if you remember inequalities, you would have had to isolate the x. This is just a nice linear inequality. So we would get the x's all by itself. But what we wanted to remind you of is when you divide by a negative, you flip the direction of that inequality, and your answer is x is greater than 6. We also want to remind you about functions, right? A relation is a set of ordered pairs, but a function is a relationship where every input, every x, goes to only one output, or y. So if you plug something in, you know right where it goes. It doesn't go to 2 different places, it goes to just one. Domain of a function is the x's, and the range of the function is the y's, right? Or the output. 8 key functions studied in intermediate algebra that you're familiar with are the linear equation, y equals mx plus b. The sketch of the graph would just be a line, right? And the domain was all reals, and the range is all reals. The quadratic function we saw earlier in our study, y equals x squared. Sketch of the graph looks like this. Domain, negative infinity to infinity. Range, 0 to infinity. Absolute value, y equals absolute value of x. You saw already. You know that that's the v-shaped function. And its domain is negative infinity to infinity. Its range is again from 0 to infinity. Cubic function, y equals x cubed. You saw that here as well. It's that snake-looking function. Domain and range is also negative infinity to infinity. The radical function, this is the radical function, the square root function. It looks like this. Its domain is not all reals. Its domain is only positive numbers or 0. So let me erase that so it's a little bit clearer what I'm trying to write there. It should be a bracketed off 0, and its range is from 0 to infinity as well. Rational function, y equals 1 over x. We saw that earlier. Looks like this. And they're going to ask about these functions in the appendix sections. And what's its domain? All reals except 0. And its range is all reals except 0. Just trying to fit it into that box. Exponential function, y equals 2 to the x is the basic one. And it looks like this. It grows over time. Its domain is from negative infinity to infinity, and its range, and this is not a mistake, is open 0 to infinity. It never obtains the 0. There's nothing you can raise 2 to get out 0. And the log function would be y equals log base 2 of x. And the graph of that guy would be, it's actually the inverse of this guy, so it looks just like this. And it's, oops, I did that again, sorry. If my hand slips over there and touches that, I'll come on down to where we're at. And so the domain is, did it again. Got to be careful there. The domain is from 0 to infinity, and the range is from negative infinity to infinity. Not, in my mind, not so important that you know the logarithm graph, but they are bringing it up here. List the domain of each function. So what can you plug into the g of x function? It's based on the absolute value function, and you can plug anything you want in there. You can subtract 7 from anything and take its absolute value. Now in b, there's a number that you cannot plug in. Because you're not allowed to divide by 0, you can plug anything you want into b. What? You can't plug in negative 3. Because if you plug in negative 3, you're going to get a 0. And then 5 minus x, the square root of that, you have to ensure that 5 minus x is greater than 0, or that 5 is greater than x, or x is less than 5, or negative infinity to 5. Now the 5 can be included. I apologize for that, because we can take the square root of 0, and that's what we're going to look at. Circle all functions with a range of all real numbers. So that's the output, right? Be careful, not the input. The first question in 3 was about the domain. What's the absolute value output? Remember, it's that v that's going up. It doesn't get any low values, but x cubed covers them all. Remember what that looks like really quickly? Looks like that. This guy's a v. We're missing everything down below. 1 over x, it's getting pretty much everything, but not everything, because it doesn't get 0. And x squared only looks like this, so it never has a range of that. Never has a range down below. And then this also never gets any negative values, but a line would do it. We could get everywhere. List the domain and range for each graph. So as we look at this half circle, we see that its domain is from -3 to 3. They're plugging in. Its range is from 0, which is achieved twice, both at -3 and 3, all the way up to 3. Oh, and it's including that 3. So that looks good. Domain here is negative infinity to infinity, but the range is from -3 all the way up. Use the list of functions to respond to each question. Okay, so here's just function evaluation. They're going to hit us with function evaluation. G of 3, no problem. G of 3 is equal to 3 squared minus 2, or 7. F of -1, no problem. That's just 3 times -1 squared plus 5 times -1 minus 4, or 3 times 1 minus 5 minus 4, or 3 minus 5 minus 4, or -6 coming out of that one. F of x minus g of x. Okay, maybe a problem, I don't know. 3x squared plus 5x minus 4 minus g of x, x squared minus 2. Okay, if we did this, we would get 2x squared plus 5x minus 6 and feel really good about ourselves, except it is totally 100% wrong. Don't fall into a trap. Remember, if you're going to subtract away something with multiple terms, you absolutely have to put it into parentheses, and you're not going to get the -6 part of that. What do you get? You're careful, right? That's what we should have learned in our algebra classes, especially if we wanted to choose a math science major like you have. We need to be really careful. We got that guy, minus x squared plus 2. And so we do get the 2x squared. And we have this 5x that's coming along for the ride. But a -4 and a 2 is a -2. And that's what we should have in that process. G of a plus 3. G of a plus 3 would be equal to, let me just rewrite it here. You're going to plug in a plus 3 everywhere you see an x. And you're going to multiply out a squared plus 6a's plus 9 minus 2, a squared plus 6a plus 7. Done. F of x equals -4. We got to find out where 3x squared plus 5x minus 4 is equal to -4. Well, that's when 3x squared plus 5x is equal to 0. And then we just factor out an x and we come out with 3x plus 5. So we got to be really, really good with our back algebra, doing most of the work very quickly. But check your answers, as as you come up with them in the back of the book. There'll be answers printed. And then be patient with yourself. Look for those mistakes. Look for common things that are done wrong. See if you can identify it with yourself. And if you can't, just let me know, and I'll look at the work that you've done and make some suggestions as to how it could go a little bit better. So our next video will get into section 1.1, but this is all the background work for us to be able to hit the ground